This is a video presentation on graphene. This video narration is being recorded as the requirement for grading purpose for one of the microsystems class in Louisiana Tech University. My name is Suraj Gimwali. With my colleague Nikesh Resta, will be giving this video presentation on graphene. So, what is graphene? A graphene is a building block of graphite. A graphite is composed of multi-layers of graphene. Normally, one layer of graphene has a thickness of 0.34 nanometer. Graphene is a two-dimensional structure with carbon atoms arranged in a hexagonal lattice like honeycomb. As we can see in the picture, the ball-like structure is the carbon atoms arranged to each other in sp2 hybridized structure. Graphene can be fabricated by following methods: mechanical exfoliation, molecular assembly, liquid phase exfoliation, silicon carbide, and chemical vapor deposition. Out of various techniques, exfoliation is the simplest method of graphene fabrication. Adhesive tape is used to repeatedly split graphene crystals into thinner layers. The strip of the tape is folded several times at different angles with itself. This helps us to spread graphite over the area of the tape. This is then transferred onto a new tape which is folded again for several times. This helps us to get thin layer of graphene which can be transferred to silicon substrate. To get rid of glue from the silicon substrate, we wash the substrate first into acetone and then into isopropanol. We can fabricate graphene in this way. And continuing with this video presentation, we will discuss a little about some applications of graphene. Graphene has a lot of application due to its unique properties like electronic, thermal, and physical properties. The potential application of graphene would be for the water desalination process, where we use low pressure to block the atom itself that cause the impurities in the water, and this is done due to the nanopores of graphene. And also graphene can be used to make the flexible LED screens and also the flexible solar cells. As you can see in the picture, the top one is the flexible solar cell and the bottom one is the flexible LED screen that can be made possible by using graphene. Some of the other application of graphene would be its use as in sensors and in graphene field effect transistors. Here you can see the picture showing the graphene transistor with the visible graphene channel and the source and drain region on top of the dielectric substrate. Graphene implemented as sensors will have an absorption of gas molecules on its surface, which results in charge transfer between graphene and gas molecules. Due to these charge transfer, there will be a variation in graphene's carrier concentration, which will generate outstanding signal. For example, a chemical gas sensor. Graphene used in transistor will have electron energy increment when negative bias is applied to the gate, and there will be a decrease in electron energy when positive bias is applied to the gates. In case of holes, they are transported in an ambipolar graphene when Fermi level is below the charge neutrality point, which is also known as Dirac point, whereas in the case of electron transport, the Fermi level needs to be greater than the charge neutrality point or the Dirac point. And one of the disadvantages of graphene transistor is that it lacks a band gap, which means it does not have both on and off state, and even at density of states of zero value they cannot turn off completely. Therefore, graphene cannot be used in digital switch. However, due to its unique carrier mobility properties and its size thickness and its stability, it can be used as fast analog devices like in radio frequency transistors. In conclusion, for this video presentation, uh, we mentioned that graphene is a few layer of graphite, where a single layer of graphene is about 0.34 nanometer in thickness. There are many researches that has been going on in many parts of the world to find the unique implementation of graphene on various fields of science. Some of the applications would be the water desalination and flexible LED screens, and these products has yet to be put in the market and see its effect on the global perspective. And as you can see in this picture, within a 10-year time there have been publication of a lot of papers based on graphene. So it concludes that graphene is getting recognition all over the world due to its unique properties of electrical and thermal nature. And that will conclude this video presentation. Thank you for your time and have a nice day.